Let's get started. We've been asked to keep our introductions brief, but it's hard to do that in the case of Balaji Prabhakar. It's actually easy to do. He's well known in our community. He's done contribution across the range of theory, queuing theory, Parisi conjecture, my favorite, many applications, including incentives in transportations and other fields. He's a winner of many awards. He's not just a star, he's a supernova of our field, to put it this way. Without further ado, Balaji, please.
Thank you. Thank you, David. Welcome to the Tuesday session. It's on urban systems, but transportation being the focus. In addition to me, there are Sid Banerjee and David Schmois giving talks this afternoon. We've tried to survey the landscape of topics surrounding incentives, pricing, data. So most of it is, of course, transportation of human beings, but there's also this enormous interest in packages these days, deliveries, especially of the online purchasing. So there's a bit of that that you'll see in my talk, but think of it all at the business of public transport, Uber, Lyft type businesses, bike sharing, okay, so modern urban mobility. I'm going to talk about congestion. So just to reintroduce myself, just to give some context, until 2008 I was really working on computer networks, that's my field. And so for about 8 years afterwards I was working on societal networks. That still continues to be of strong interest for me as a topic. But it started in December 2007 when I visited Bangalore, and I believe Eva Tardosh was in that, we had dinner in that particular year in that same December. If you remember, we were there with Pierre Kumar and Jean Laurent, so some conference. That was it, and I'm sure if you've been to Bangalore, you've seen this. You've been in this, and one of these people somewhere is me. You know, one of these out-of-body experience photos. This is sort of normal in Bangalore, and it's the sort of thing that one wants to do something about if possible, and so that's how I got started. We were designing nudge engines. Nudge engines are just a system for administering nudges, in this case paying money and getting people to shift. Okay, and this has been deployed in several places. The first of these was started in Bangalore with Infosys technology. So don't address the Bangalore congestion problem, but try and see if you can move Infosys commuters. There's about 20,000 of them. Could you move enough of them to the off-peak time for travel, paying them some money? Okay, that's the idea. And then on the heels of that project, we ended up doing other ones like Singapore, Stanford, BART also used this scheme, and then not just for transportation but also for wellness and recycling. So you'll see how that works. This led us to form a company to supply the solution to the user. So this went beyond the initial pilot phase, and this is where the transportation companies or the logistics and delivery type got involved. Now Urbaninz is part of Google Maps. They have a ton of maps data, and so that's where it's sitting. In the presentation, I'm going to just focus on the yellow points, briefly describe urban congestion. Really, there are lots of obvious images, but I want to come up with a cost, because then I want to address that cost of congestion here in a theoretical model. And then I will briefly describe the two major components. One is to shift demand, the other is to understand supply, and then I'll elaborate on each of those components. So we've all seen or been in places like this, Bangalore, or that's road in Bangalore, buses in China. This is the famous Japanese YouTube video, the Shinjuku train station these are employees of the train company. Okay. It's called Wuxia. The title of the job is Wuxia. It means the passenger arrangement staff. Okay, so it's compressed before transmit. Okay, so this is it was a 100-kilometer long traffic jam, single traffic jam. Lasted 9 days, and it disappeared in 3 hours. So it was amazing. Nine days they couldn't sort of get anybody to move, and then 3 hours it just disappeared. And so these are sort of really big problems, and increasingly we're getting into that sort of mode. And it's not.
What happened, Balaji? Is there actually some road broke?
There were, I believe it was the trucks that were bringing coal from Mongolia, Inner Mongolia. So there was a larger than typical number of them. And so this is an example of the small perturbations. Systems are now so, demand and supply are so equal that you just mess a little bit, then you pay for it. And unlike computer networks, where the whole goal is to have roughly 10 times the bandwidth you think you need, so no computer network is allowed to get more than 10% congested, typically. And the people are aspiring to 30% in cloud. But that extra slack allows us to have distributed protocols that don't necessarily have to be optimal. In urban systems, that kind of slack is unaffordable. So either you have too much, in which case the taxes are going to kill the people, or you're almost always on the knife edge. So there's some cost to this. If you calculate the extra time and fuel spent by vehicles stuck in traffic, in the US, the Texas Transportation Institute puts a number to that. This is the extra time and fuel, not the cost of transportation, but the cost of congestion. And that's those numbers. It helps to make a dent into this number by about, let's say, 20%. That's meaningful. Okay, one can do it. They publish something called the Urban Mobility Report, and they break it down by region. They tell you how they're calculating this. Then there's emissions due to traffic, which transportation as a sector is the biggest or second biggest in the emissions category. And then there's also safety. I don't mean just road transport, like just fatalities. That is, of course, very bad. But even other things like when you go to subway systems, just the crowdedness demands that people don't be, if the only way you can exit the platform is the train, and then it's the so-called open platform like New Delhi or London, where there's no barrier between you and the tracks, you have to stop people from entering the subway station in the first place. Okay, and London Tube, the underground trains stop before arriving at their platform to let the people from the previous train leave. Okay, so this is just affects operation itself. Okay, so this is important, very important. So the basic problem can be, it's just demand is much higher than supply. And we would like to work on both sides, and one side reduce demand, taking an incentive approach, not a charging approach. Both are, can coexist. We're interested in this from what's the possibility, how much money does it cost, etc. perspective. And then increase the supply by understanding where there's slack in the system. And often there's slack in the following way, that if you look at most subway systems, in the morning peak hour, almost all the traffic is to the downtown or the business district, and the trains are going back out empty. It is possible to flip one in 3 or 1 in 4 trains at some intermediate station, rather than send them all the way back up the line, because it's a 45-minute trip. And this is done in many cities, so you can have your supply be closer to demand. That's an example. But the real problem I'm going to claim is not so much the supply is exceeding demand. We have a data transportation architecture, and I think that's the one that the Lyfts and the Ubers are all disrupting. And what's classically done is, this has been around for just since the Romans. Somebody builds these roads or infrastructure, like these guys. Some of those guys build these things, or run a bus system in a city, or subway system, or a taxi, company. And then commuters are using them. So basically, this is how it is. The only place where these two meet is here. Okay? And so, unfortunately, this just doesn't let the supply and demand talk to each other. And what I mean by that is, if you replace this with an app and abstract this out, then whoever's offering the service directly gets in touch with the commuters. This is also the model that airlines used to use until the mid-80s. They were the first to get rid of this model and directly relate to their passengers because it's airline frequent flyer programs. Until then, no airline really knew who was flying necessarily. Okay? Nor did they care to cultivate these people. It's not necessary. But now, they're the first ones to have done it, and then now it's hitting the rest of the road transport world. Okay? And it's hitting both on the driver's side as well as the passenger side with Lyfts and Ubers, because they have to keep both sides of the equation on the supply and demand side, in their, they're dispatching both, so to speak. Okay? So the 21st century thing everything is sort of moved into the cloud, right? There's some app over there. You can offer incentives. You can get real-time usage data from the fleet into the network, and you can get user behavior data. When does this person want to leave? Where do they normally go from? What kind of vehicle do they typically prefer? And then you can offer real-time analytics. And what's happened is simultaneously several pieces of technology have fallen in place. First, we have this very cheap and ubiquitous sensors, and there's tons of bandwidth. So this all wouldn't have been possible even if we had dreamt of it in the pre-internet, pre-smartphone era. It's not possible. So somehow everything is just right. Everybody's got a smartphone, and then there's all the other stuff, okay, in the background. So it's sort of, we would have had these bad societal problems if the internet and smartphones and all hadn't happened for another 50 years. All the societal problems would have been just as bad, because you can dream of these things, but without this technology you can't do anything. Okay? So just as when things start getting bad, luckily for us, a parallel network has a reason to help us. This is not just for movement of people, I claim. It's also happening, this is exactly what's happening in commerce and retail. It's the exclusion of this middle interface. This has been so in all of the great 20th century commerce and retail invention is stores. Okay? This is the great department stores. Chains of departments, this is the great 20th century invention. Okay? In the early part of the 20th century, all the barons were chasing up and trying to set up one of these chains. This is like the holy grail. And the consumers, so these guys who are producing goods just stock these stores, and then we just go here. Okay, this is the model for 50 to 70 years. This is the model. Sears, everybody. Okay, and it was great. I mean, this allowed a certain production of goods and food especially, and the disbursement of it. Okay, and a lot of operations research went into this portion. Okay, so where do I locate stores, facilities, etc. And now, 21st century, those two sides, the consumers and the producers, exist, but everything is just into the cloud. Okay. And of course, Amazon led the way, with lots of other people doing it, but including some of the stores now have a tremendous online presence, with them often boasting how much of their revenue is coming from online, the online portion of the business. Okay? And so what's happened is that there's listing. You list yourself in one of these things, and then you buy online, and then there's a home delivery component. Okay? So this is also very interesting from a research perspective. It's not settled by any means. It's sort of whether you're looking at how to make maps at the street level, or you're looking at innovative delivery mechanisms like drones and stuff. So this is tremendously interesting. I would say the next 15, 20 years we'll be doing this. And then there's, Amazon's first, unmanned store opened in Seattle just just Monday, maybe yesterday. Okay, and so this is all happening. Okay. So with that background on like congestion and what's the cost and where's the world heading, let me describe a few things about nudge engines. What's a nudge engine? So this is the landing page for a user, anonymized to Mickey Mouse, okay, from the program we ran at Stanford called Capri. This was aimed at Stanford commuters. 4,000 drivers signed up, and it ran for 2.5 years. It was a DOT-funded project to determine if what happened in Bangalore with Infosys employees could be replicated here. Could that same thing work with a different social demographic and with a different mode of transport, namely driving primarily, okay? And so the main elements I want to focus on, there are many things. One is money. So this is a ticker tape. How many minutes ago or hours ago, what were the winnings? And it's paid out in the form of lotteries, and I'm going to describe that. Second is the effect of friends. So what's the effect of money on your behavior? What's the effect of friends on your behavior? Now finally, what's the effect of personalized offers? Okay, I'm going to describe these three things. Are you okay with this? So feel free to ask me questions as they come up. It'd be nice to have it interactive. Okay, so the reason I started working on this is I met this person, Praveen Sood, in Bangalore, 2007, December, and he made this comment. There's a willingness to, so I was asking him, why don't you do congestion charging? And he said, there's a willingness to pay in Bangalore, but there's no willingness to charge. Okay? So this is political suicide. You don't get elected. Ken Livingstone in London did it, actually. That's his election platform. He did it. He got elected, but not again. Okay, just once. Okay? And so Bloomberg failed to get it past Albany, New York. So it's not a popular thing. People don't like it. And also in places like Bangalore, it's very easy for commuters to say, I know why there's congestion, look at the roads, okay? So first you give me bad roads, that causes congestion, then you charge me for getting rid of this problem that you caused, okay? So this is not an easy thing to, it's a monopoly system. There's only one set of roads, okay? So, but the question is there a willingness to accept payment? So suppose, we were to offer money to commuters, and would that be interesting? So this is the starting point, and so how much money would it take? Okay. So to norm this, London, I think it certainly charged £10 every time you enter the central business, the congestion cordon. It started at 5 and then it increased, and I think it's maybe £10 have gone up. But you can't charge £10, you can't reward £10 for every off-peak trip someone makes. That's just, this is not a sensible thing. And to give you an idea, for the DOT-funded project at Stanford, we had $1 a week per participant, and that $1 a week on average, that's the average payment in the pot. So there are 4,000 people, there'll be $4,000 in the pot. And that was to be given as 10, there's 5 morning trips and 5 evening trips, so a commuter could make 10 trips in the week. And so for each trip, on average, there was 10 cents. So for 10 cents, I'd like to induce a shift to off-peak travel in a commuter who's earning a lot of money, okay? Certainly 10 cents is. So now, can this be done? That's the question, okay? And so also, how does one work with equations like that? How does the pot of money and how does the payment? There's a very interesting set of things we learned, okay? And I think there's some neat algorithmic questions as well there. Okay, so this is it. So can we do it? Yeah.
This is maybe backing up a little bit, but going into the willingness to charge. I mean, in our area, there's the history of gas taxes and explicit use taxes for commercial. That I mean, it's bubbling up with a new proposal, but it seems to be part of the landscape. And
So commercial use, I think, is easier.
It's there on
Yeah.
that time scale and that expectation of maintenance and improvement that's different from maybe the congestion of labor.
That's right. That's the key point. So tolls are fine. When the Bay Bridge got done for $800 million, redone, tolls went up. Okay, but tolls are not about congestion. The label is really the key point. Gas tax is similarly under. It's sort of, there's a slightly higher penalty that hits people who are stuck in traffic and burn gas, but it is levied again in similar ways, like it's just gas tax. Okay. Oregon does that, for example, quite a bit. And so when you have to levy a tax that's not directly related to congestion, you get away, but congestion charging, it's coming here too. Like there are some lanes now that are express lane, high occupancy toll lanes, hot lanes, that weren't there before. So California has land of freeways. It's not like that anymore. Okay. So
Washington, D.C., within the past year, has set up on the Dulles tollway, set up an express lane that people are paying $40 a day.
yeah. So
And the toll is congestion sensitive.
yeah. No, I think it's happening, but it's not been an easy thing to push. I think the problem is now so severe that this willingness to pay is going up. That's really what's going on. And many of the people who travel that way, I think they're billing it to, as a business expense. It'd be hard to justify personal expense at that level. Okay. So how does this lottery thing work? Again, just sort of quickly going through things. There's this sort of well-known two-envelope game, and it goes like this. It's a sort of standard, first lecture in economics on utility functions and stuff. If you're offered two envelopes, one of them has a deterministic amount of reward in it, $1,000, and the other one has $110,000 with 1% chance and $0 otherwise. Okay, so on average, this pays you $1,100. Which one will you choose? Actually, can I just get a show of hands? Who will choose envelope 1 versus envelope 1? Okay, who will choose envelope 2? Someone's paying a lot of money, guys. You guys are like, okay, wealthy people. Okay. Or the gambling instant, whatever, okay? So, which one would you pick? We've already answered that. But now suppose I offer the same game where the dollar values have gone down by a factor of 1,000, okay? Who will pick envelope 1 now? Who will pick 2? Okay, so you get this point. You can prove a theorem as well. With concave utility functions, you can prove that even with that conservative thing where people are not risk-seeking, you can still prove it. In games with low stakes, hence lotteries can matter in these cases, and can be used rather, can make a difference. So let me start with testing this hypothesis. So this is out of chronological order because we did this first in Bangalore in 2008, but I'm going to start with this. So as part of a freshman seminar course that I taught, we had, and I think the experiment ran because the freshman seminar class, there's no undergrad, grad class, this experiment, because it requires students to get excited enough to do this sort of stuff. Freshmen were great, okay? And so in the state of California, for recycling the small cans and bottles, you get 5 cents, and for doing the bigger ones, you get 10 cents. So let's look at the small ones, and we offered the following to people at Stanford. Okay, so bring your recyclables, and you get to choose per recyclable which of these options you want to get paid according to. Okay, either the 5 cent option, or on average 5 cents with different odds. Okay, this is just to know what's the risk profile. Just even tested hypothesis that I had written in the previous slide. Everybody okay with this? And so the first version of this was offered literally like a lottery in the following sense. This is a MATLAB program. This is in fact the screen itself. And you came and you had, let's say, 5 recyclables that gave you 5 runs. That's what this means. Okay, so you have 5 cans of bottles, and you said, I want to try all of them for the $5 option. Okay, You could do one at a time with different values, but it's your choice, okay? And then you would sort of have a little bit of a think time when the coins got flipped with the right bias, 1 in 100 in this case, and you either won something or you didn't win anything, okay? This ran for the first 2 days in a 9-day period, and the thing we noticed was some people just came and gave the recyclables, and phones had just come out, students all had phones. And they weren't interested in the draw itself. We could have announced the results by newspaper. They just weren't engaged any further. They just gave the recyclables and just, okay? I will show you the results of what they did, okay? So we thought that this would be nicer if we could engage them. Plus there's also this thing of how do I know the odds are what you're claiming they are, okay? So second time, the third day, we did this instead. We created a game. The same recyclables, 5 of them that you came with, we let you pick 5 tiles out of this 100. So $5 each one is supposed to be 1 in 100 odds. This is a 10 by 10 tile grid, so the 100 tiles. One of these tiles has got a $5 behind it. With your 5 trials, 5 choices, you get to discover this magic tile. Are we okay with this? For example, if you pick the $20, the odds of that is 1 in times 4, so 400. So it'll be a 20 by 20 tile grid, and one of those tiles has got $20 behind it. You would get to flip and discover it. Everybody okay with this? The 2 versions are not identical, obviously. Here with $5, if you had 100 units, you would for sure win $5. Okay, there you would win it on average. Okay, so it's sampling with and without replacement. That's the only difference. Okay. But anyway, so this is what we offered. Okay. And people would come and select. They would select very carefully. Like it matters which type, They would consult with their friend, okay. When something like this happened, not even this close, but somewhere nearby, the winning tile was here. I was so close. Okay, so there's this sort of there's an emotional component to the whole thing, which actually was the most interesting aspect to us. Now they're engaged, it's sort of interesting. The odds are made completely transparent. It's well known in prospect theory that the ability that we have for understanding very small probabilities is not that great, whereas this makes it completely transparent, which was great. There's also a mini puzzle as to how can I assure you that sneakily I'm not moving the tile to some location you didn't pick, right? And anybody want to think of this puzzle? Well, if you go to a machine that offered this thing, you could have the machine print out its choice, and the paper's already there. It's committed, its choice. So all you have to do is verify post facto, okay? It's going to let you see the paper after you finish making a choice, and so there's an online version of this you could do if you're doing it online, okay? But the way it works in practice in Singapore and all that, we have to get a game license, so there's Singapore Police Force. You apply, send the code, they audit you, make sure it's all fair, okay, as declared. And state of California, there are sweepstakes laws that cover things like this. So Stanford's General Counsel had to sit and look at all this stuff, okay? So there are things that are governing how you do this, okay? Anyway, so this is the second version. The other thing we found in addition to user engagement was simply that, for example, what I mean by user engagement. Some student came, was doing the $20 option, so it's 20 by 20 tile grid, and they had 70 recyclables or so, and they drew a face, okay, eyes, smiley, okay? So this is like somebody who just didn't want to just choose tiles at random, okay? So you get the point. So in addition to all this, we realized that this is self-administered lotteries, and we don't have to be doing this weekly draw, which is what we did in Bangalore. Because then Bangalore Infosys employees would write in saying, I want to opt out of this week's draw because I'm traveling on business and I don't want to be docked. It takes some amount of points from your account to be qualified for the lottery, so I don't want to lose the points because I'm not around, okay? I can't make the points up, okay? So I'd like to opt out. So this opting out, opting in, it just got to be a headache. With this, it's sort of simpler, okay? Airline miles programs could do this now. So if it costs 50,000 miles to get a ticket from here to New York, let's say, that could be offered in that way, which is the way it's offered. or they could give it to you for 500 miles, but 1 in 100 chance. Are you okay with this? So on average, for every 100 persons that try that option, the airline gets 50,000 miles on average and gives one ticket. Right, its books are balanced on average, and all of us give lots. One person is super happy, and 99 people are moderately or hardly unhappy. Okay. Yes.
There is the notion of some trust involved, with usually some trusted intermediary.
So that's what I was saying about you can commit your choice in this case, or you get audited. So when there's a public entity or anybody who, are you talking about just how do I know you're doing the thing correctly?
In abstract,
yeah. Yeah. So that's right. So this is very key. I mean, this is not a simple step. Audits are conducted, and there's this serious penalties, and you get. So sometimes these draws are conducted in the open. That is, you draw a person from the street, pull them in, and say, pick that thing from this bowl of possible things, and I'll take down your name. And did they do this? This is just required by law. Okay. So as I mentioned, so this is key. For the moment, we can leave it as how the law legally is being done, but it's a computer science question as well. Okay. And one of the answers is the one I mentioned, where you commit the choice ahead of time. Yeah. Are you okay with this? So what happened was people did choose as we expected, but somewhat unexpectedly, lots of units went at the 5-cent option. But if you look at the total number of users who made these choices, 3 people were responsible for that. They actually came together. They apparently go recycle. They just only drink bottled water. Stanford kids, okay? And so they came, their weekly recycling happens for them, and then they came, 3 of them together, and they just found us to be closer. We told them, guys, we'll pay you money, don't give us this. There's too many things to carry, like it's a big bag. And so anyway, those were 3, and everybody else chose how they did, okay? This does sort of validate the risk-seeking sort of behavior. And I think that this was something, again, this is an interesting, this currency node is not heavily in circulation. So I think people have chosen from the nodes that are heavily in circulation the right odds. But this is what we offered, okay? So that's what I'm going to tell you about in the first go about incentives paid through lotteries, administered through games of chance. So for Singapore and Stanford, we didn't do this game of chance, we did snakes and ladders. Okay. Much easier. When you're into games, you sort of realize there's this things called narrative. Games have to have narratives. This is too episodic. This is too episodic. I mean, it's just, in other words, you do once and then there's no progress, there's nothing. Video games designed like this are bound to fail. The only reason they may work is simply because you're paying them money. Okay? Whereas if you have progress and you say, oh, look, you're up on the top of the board, people get the hang of it. I mean, they like it. Okay? So we got sponsored by, as a research donation, by the guys who did Guitar Hero, and they told a number of different things after the games have been done. They came around and they said, yeah, we see that you've got these elements, okay? In this sort of snakes and ladders, there were some tiles that had extra bonus payments and like various things. And they said, oh, that's called the Easter egg. You have to have an Easter egg in games in every level. And then you have to have levels, and people do what's called level grinding. This whole thing is apparently well known, okay? There's a whole science on how to get people to play games and stay engaged, okay? So we just happened to have hit on some things, and we learned after we spoke to them and then started doing this deliberately, okay? Okay, so that's what I'm going to tell you. Any questions or comments?
Did you account for framing effects when you looked at the recyclers? Like somebody who's wealthy might not be willing to spend time in clicking and just wasting.
I agree. No, we didn't. We didn't have questionnaires and stuff like that. First of all, when we were doing this, I didn't even realize that we were going to have people, lots of as many people as these come. And I don't think they were all the class students as friends. They were just random people. In fact, we had it outdoors near the dorms, and someone would see us and walking back from lunch or something and say, let me bring some recycle stuff and then play it and see what happens. So it's more that way. But they're all Stanford students. That gives you more or less, okay, that gives you a certain base.
Is there a way to, so there is some novelty attached with doing this, right? So is there a way to separate out the novelty aspect of it and like the long-term sustainability or something like that?
Yeah, so that's where I'm going to summarize everything by showing the Singapore project that had the analysis is for 5 years. So to your point, since people may not come to play the game because it's not exactly, you know, the thing on top of your mind, you know, unless some friend of yours, in things like the snakes and ladders, not only is your piece moving, but you get to see your friends' pieces, okay, when we design it that way, which requires some extra work. But so now people have a reason to come because your friend won some prize, and then, you know, it's like that, okay? That is, you get these notifications. But I'll show you how. But what we did was to not have to worry about this. We had a weekly autoplay option. So whatever points balance was in your account, you could choose to autoplay them, and the system would just play them for you. I think Sean and then you.
Yeah. I mean, just when I saw you present this a year and a half ago, the world could have been run on Pokemon. I mean, everyone was obsessed with Pokemon. And, you know, just incredible. And people excited about it because they were together.
Yeah.
And there was just an explosion. It just collapsed, you know. And that's scary, you know, when you think about, you know.
Yeah, this is a bit of the novelty effect thing.
Yeah, I mean, but I don't see there's any way to...
So the thing here is that people have to commute, right? So the most important thing is look at all the projects we picked. We didn't stick with recycling too much because you don't have to recycle. Okay, this is one of those things as academics, worthwhile to pick projects that, you know, you have to commute. You have to take a shower, hopefully, okay? So, in other words, we do water conservation, that's a good project, okay? I just measure the flow and the temperature of the water you're using and then nudge you to do the right thing. That's an example, right? You essentially have to walk. You don't have to undertake physical exercise, like go to the gym, that's harder. But how about the Steptacular project is to get you to walk a little bit more, right? So if you go after the necessary activities that we do and then just nudge that, that's much easier. You have to eat, okay? And it has to be frequent. It's not something like buying a car, which is once in a while. There's no point in nudging, there's nothing to nudge there.
There's an interesting socioeconomic dichotomy here in that if you impose a huge toll for the privilege of using an express lane, that appeals to one particular segment of people, those who have money to burn. Small payments of a nickel for recycling a bottle tend to engage the other end of the economic spectrum. Is there any way we can get everybody engaged?
No, I think maybe the thing you're saying is that, so you charge those who are willing to pay. Okay. So apply congestion charging to those who must go in the peak hour and can't afford to pay for it. For those who don't want to do it because it's too expensive, reward them. So the two can coexist, okay? It's a bit of like a Robin Hood system, okay? Let me continue because I have a few more things to say and then I'll come back to questions at the end. Social influence, okay? This wasn't immediately obvious to us, but there's a lot of social psychology literature on this aspect. There's also a book by Robert Cialdini called Influence, which is surprisingly used by a lot of people who do marketing. Okay, that somehow is like, you know, you talk to a marketing person, did you read Cialdini's book? Okay, it's like, you know, it's like, I don't know, Papa Dimitriou and, you know, one of those kind of, you have to read these books, right? So, okay. So, the effect of friends. So, friends can play two really important roles. One in recruitment, they can include, you know, it's like free marketing. And second is to help with behavior shifting. So let me show you the first thing, recruitment. January 10, 2012, we launched this program in Singapore, Insinc. It stands for Incentives for Singapore's Commuters. And it's now called the Travel Smart Rewards Program, so in case you want to go look for it. And it's still going on, okay? There were 9 newspapers in this press release, 9, okay? So they're like English language, Mandarin, Malay, Tamil, they're all there. TV stations from all the languages, all the major ones. Radio guys, everybody was there. I thought, like, this is, the whole island has heard it. There cannot be anybody that has not heard about this, okay? Completely wrong. It's just didn't. We only had 3,000 people signed up towards the end of the month. Okay, but there were some things like, you know, the press just fell off after the, you know, first burst. There's nothing keeping us in the news. Chinese New Year came, and people, of course, you know, everybody tends to do their own thing. On February 14th, Valentine's Day, right, so we did the recommend a friend system. So this is just to link to your web account was Facebook Connect and Google Yahoo Connect, so you could just invite your Facebook, Google, Yahoo friends. And if you did that for every friend that you recommended that ended up joining, and we had sort of ways of verifying, they just carried a token and brought it back, right? You got 250 points. 250 points is 25 cents in monetary terms, but it represents 1 week worth of commuting. It's 250 kilometers, okay? So you see the dollar value is so small, but then when you survey people, they think of how long it takes to earn those 250 points, okay? So we found this is a nice way of representing it. Okay, and they joined. So here's how it went. So signups went increased right away, and then the percentage of users as of the dates that had joined because of friends here. Okay, and soon enough it crossed 90%. Okay, so almost all of this came from, and the user acquisition cost is just 25 cents. So if you ask Facebook or Google or Amazon what they're willing to pay, it's somewhere in the $10 to $20 range. Maybe more. I'm sure Lyft and Uber will probably pay more, maybe in the $40 range. Okay, so it's not an easy thing to do, but again, people have to commute. There's not, you know, it's like I'm not going to induce you to go to Amazon and buy something. That's not what I'm doing here. Okay, so I'm going to say there's more to say about recruitment, but I'm going to move on to what's the effect of friends on one's behavior. The blue line for this program, Steptacular, this is the idea was Accenture USA employees signed on, and the reward money was $2 per signed on person per week. And the more steps they walked, the more points they got. And this was measured through a pedometer, which they used to upload their steps to their site. And this is what happened, okay? This is the average number of steps taken by participants during each week in the program. This is the steps taken by those without friends in the program. Okay, so this is about again, this is increased over time, and this is the number of steps taken by people with friends. So numerically, you can see the number of friends you had as it increased. You tended to take more steps on average. This has been a fairly constant invariant in every, yes?
So you don't know if this is causational or just you're more likely to connect with your friends on this if you're actually more active in the program.
So,
do you know?
in this case, we didn't have this from day one. We launched it about a month into the program, okay? So we had their behavior before, their friends, and then I'm showing you just the portion that had friends, okay? Again, people who are more social, so there's a particular answer we give in the paper to that question. It's not directly inferable, but we demonstrate, and I can tell you more offline, that the friends are actually causing, in this case, because of the before-after data, as well as an argument that separates out the propensity for people who tend to be more social to sign on their friends, but also those people may tend to walk more just to begin with, okay? It's not conclusive, okay? But there's something else that is more conclusive, which is this one, the probability that a user will stick to the program. Several people lost their pedometers, okay? These are not, you have to buy it, it's a $30 pedometer. Accenture reimbursed you for it, but you had to buy it. And unfortunately, about a dozen or so of them lost, maybe 2 dozen of them lost this pedometer out of the 3,000 odd people who had pedometers. But when they got friended, they went and bought themselves a pedometer. Okay, that's just somewhat more clear evidence. Friend nudged them and then they, okay. But this one is, again, what's the probability you'll stick with the program? That is, you continue to walk and register your, behavior. Okay. But there's also something that's well known in these programs, friends are not appreciated, meaning we don't tend to credit our friends, even though there may be friends have an effect on you. When surveyed, of course, we are the reason why we're doing good things, okay? This is Steptacular, so what is the reason that most encouraging? Check all that apply. You know, setting goal, you know, this is the least, comparing, somehow the friends are just like, you know, why did you join the program? There are other questions too, okay? And so, even when they came in through a friend recommendation, they're less likely to credit it. And this is actually known in Cialdini. Cialdini worked with the O-Power guys, and that's another social norming sort of energy thing that was very popular. It's now bought by Oracle. It was observed there in a similar way, but with different measurements. Okay, so here's another Insinc survey. I see my friends doing it. It inspires me to do the same. 90% of the people joined the program because of the friends. No credit, not much. Okay. Okay, so I don't have a lot of data to show you on personalized offers, but by far this was the biggest of the three things in terms of making the dollars apply correctly. So what I mean by that is incentive programs suffer from this adverse selection problem, meaning that those who are most likely to exhibit the correct behavior will join the program first.
Balaji, on this question, maybe it's because how this question was phrased. Because one thing is to say, I've learned about this program because my friends told me, and probably many of them would say, yes, I did it. But we don't do really things because my friends tell me to do that. I do that because I believe in it.
Surveys are carefully constructed, and then there's this A/B testing way of asking question A here and slightly different question there and so on. And then with large enough population, even though you're not asking the same person, you can get a comparison. We didn't end up doing that. These things you get a week's time to get the survey up and going, so it's sort of, most of the effort here was spent like just, you know, the automated response to this is not working, and you know, how many points am I earning again, and what happened to my, you know, it's like that. So there's a lot of administrative overhead that hit us, which was surprising, but you're absolutely right. We didn't, also, you know, in runtime, so to speak, some of these things we didn't even register, okay?
Understood.
But you're right, okay? So adverse selection, Accenture, the first few people signed up to this program were the marathon runners, okay? And of course, they're, you know, that's what's going to sign. I mean, it's just meant to walk more. And so because of this, many incentive programs have the worry that the money that's being spent is inducing a lot less behavior shift than desired. So there's a metric called dollars per shift that is important, okay? Personalized offers allow you to do this because you can target people who aren't shifting their behavior adequately and then give them extra, you know, sort of 50 or 100 points more for making trips in the off-peak time or whenever it is that's desired, okay? And it also encourages participants to visit, so this could also be, what I mean by behavioral is I found that David doesn't like to travel in the off-peak time of Mondays and Wednesdays because he has an early morning class and he has to be there on time, whatever it is, he's got his reasons. But if I ask him on Tuesday and Thursday evenings, he's always willing to go off-peak. So I've learned that that's the case. That's what I mean. So you can nudge specifically. And that he costs a lot less compared to David Schmois, for example, okay? So it's like, you know, he'll do the same behavior for like 20 points and David wants 200 points. So, you know, that's what I mean, okay? So that's how we can decide these things, and then we were nudging accordingly. This is probably the most, you know, there's a bunch of things here that we did, about at least a dozen of these, and they were really very informative. The other thing it did was, we found that an engaged participant, just plainly, the more times you visited the site, the more your behavior shifted. That's just something we just found. So I'm going to conclude this whole thing by showing you how all this comes together in one project, the long-running Singapore project is runs even now. Okay. We launched it for a 6-month university trial, and then it got taken over by Urban Engines as an offering or a program. By summer 2016, it was called the Travel Smarts Reward Program by then, and then there were at least 400,000 people signed on. plus 70 or more companies. So companies could join the program and enrich the pot, for example. That's something that was done by BART, as well as the program in Singapore. And you could join as a corporate member, and so your employees join together. And so this was the status of the program, and then the overall shift, I'm going to show you more details, was at least 10%. Okay. So the program itself was you travel with your smart card. We saw your where you entered and where you exited. That gave us a distance. And for every kilometer you traveled, you got a point. If the trip happens to be in the off-peak time, then you got 3 or more points per kilometer. Okay, it's exactly like an airline miles program with an off-peak, bonus. This is it. Okay. Then you could go to your website, and you could look at your history of rewards. Like, think of United Airlines, or whatever your airline program is, miles. And then you could go and redeem this for cash, or sometimes in-kind rewards. Okay. For example, at Stanford, we used to give football tickets. Okay. And the thing of like latching your program onto something that's local that everybody knows, so you don't have to get free advertisement. It's called trend jacking. Okay. Trend jacking is like, they don't allow it. So if we also try to do this with FIFA World Cup. Because, if your favorite, you had a hero team and a villain team, and your hero team wins, you get 3 times the points on that day for your trips, off-peak trips. And your villain team loses, you get 3 times the points. Okay, but you can't brand it as FIFA. FIFA is just like they just will descend on you like a ton of bricks. So don't mention FIFA anyway. Nothing. It's just Okay, so you get the point that it's amazing because everybody's watching this. It's just sort of in the consciousness of people. Okay, so what happened for the first 6 months, and we wrote a paper on this, so that's available on my website. If you look at people, so you'll see numbers like this. This is 5 a.m., 12 noon, and is what fraction of commuters were traveling in what 5-minute segment. It's a PDF. Okay. The blue is the before. So we have 3 months of commuting history for a person before they join the program, up to 3 months. Okay. And then the orange is the after. Okay. So this 8 to 9 was the peak hour. So the goal is to avoid this. And you got your 3 times or the extra points in the orange zones. Okay, this is where you got extra boost. If you travel really early or after this time, you just got the 1x. You didn't get the extra boost. Are you okay with this? What's going on? So the goal is to try and move people away from the peak, and this is how it worked. This chart shows how it is for all the commuters. This includes the people who are already traveling in the off-peak hour, okay, of which there are at least 20-25%. This is for those who only traveled in peak, to made at least 5 peak time trips before they joined the program. Okay, this is a subset of all users. The subset being the ones that traveled made at least 5 peak trips. So they're mildly traveling in the peak hour before they joined. So for them, there's more to shift. And this is at least 10 peak trips before and at least 20 peak trips before joining. So mildly in the peak, medium in the peak, and heavily in the peak. Okay. So in general, they just have more to shift. There's more, you can expect more shifting. Okay. And so, yeah.
So there's this weird effect on the very first plot. There's a bunch of people who go just to get the reward, like,
Talking about the small bump here. Yeah.
Bumps like, no, the top one, that one. Top 10 seconds before when you start giving them reward. And that shift isn't like maybe a teeny bit there on
That's right. So if you zoom in, you can see it here too. This is almost like.
But the next one is totally gone.
That's right. So there's a much better explanation of this in the Stanford program, and the reason is, so many of these guys, the ones who were traveling heavily in the peak, were usually, if you look at where they were traveling near the edges. Okay. So we didn't end up, so when we look at the non-heavy peak time travelers and everybody else, there's a bit more, the peak here is more pronounced. So this is the propensity for people to travel in the peak who responded to this program. They were the ones who basically had to shift only 15 minutes or so, roughly. Okay. And they ended up, in general, traveling in the peak more here, and they were able to shift. But we didn't have this kind of a pronounced effect. In general, when you zoom in, you do see a small, but it's just too small to observe. Also, this is the number of commuters in this category is 36% of all commuters. Okay? By the time you come here, it's only 19%. But then you ask how many peak trips are contributed by these guys, by these 19%. It's in excess of 90, so this is 95%, this is about 75%. So a small number of people make the majority of the peak time trips. So there's that thing too, okay?
These are round trips?
No, just morning trips.
Just morning?
Yeah, so 5 a.m., noon. Okay, so you're going to see these kind of phone numbers, but according to categories now, like those who play the game, those with friends in the program, those without friends, those who played the game, those who just opted for the fixed exchange. 25 cents or $1 equals 1,000 points. That's what I mean, the fixed exchange. Okay? Short distance, long distance, etc. Okay? Now, the all in the group skews these numbers because the all in the group includes all the people who are traveling in the off-peak, even quite a bit before they joined the program. And it's just, especially in the distance category, this was, short distance commuters are predominantly traveling in the peak time. Just because they don't have long distance to go, they don't have to endure horrible congestion for too long, they don't really care, they're only going 3 or 4 stations. Long distance commuters are typically already, trying to avoid the peak hour. So there was some skew in this whole thing, which we remarked about in Minwook's thesis, but this is summary numbers. All mild, medium, heavy, okay? This is just the first 6 months. And then, as you look across the years, this is again all at least 5 and so on. But the thing is, this got normed to what happened to their behavior, some of them before they joined the program altogether, right? So some renorming over time would be good. Also, the system itself was adding more lines. So it wasn't the same system, okay? People had other routes to take. What happened was, luckily for us, such an opportunity arose when the government wanted to change the peak from an hour to an hour and a half. Okay? And so now you have this thing of like, I'm trying to, I already did this and I'm going to give up and just stay in the peak, or I'm going to adjust to the new peak and shift out of the new peak. Okay? This was an interesting, it was great. From an experiment perspective, it's great. It's like, we have a system-wide change. Okay? I'm just going to show you the summary numbers, but there's more in the write-up. The key point is that against the new metric, everything drops just because you're still measuring according, the behavior was according to the previous thing. So it all drops immediately. But it picks up again, and often either a person was going to make the effort and change, or not, and this was decided in the 2-week period. This is it. If in 2 weeks they don't change, they're roughly never going to change, with a high chance, 85%. Okay? So that's interesting because, it's sort of, we found this, we had categories like newbies was, sometimes people don't understand rules, like what is the peak hour? It's not obvious. And so, when we ran surveys checking on this, people often didn't know what the peak hour was, okay? So, let me go to just 2 slides and I'm done, okay? Those with friends, similar to the thing before, no friends, 1 friend, 2 friends, etc. Okay? The trend here is, again, the more friends you have, the more you tended to travel in the off-peak, okay, over time. This is something interesting because does it actually promote loyalty to the public transit use itself? Because you have the option of taking car or some other mode of transport. In airline miles programs, it's known that people, once you have a number like, miles earned, people always try to make that bigger, okay? every day the mileage runs. You probably heard this. I have to go to this meeting in Europe for my business meeting, and it's necessary, and then you get approvals because you're on the border, and you need to bump up. Okay, this happens. But what about public transit? Because it's everyday behavior. Okay, so the expectation, you already think that it's going to happen, and you'd be surprised if it didn't. But the question is, what's the extent? So if you look at people who joined and the weeks before they joined, we're looking at people who made only 0 to 2 trips at all, not peak, just trips at all in the public transit system. Are you okay with this? This has nothing to do with peak, it's just pure trips at all. And this is the overall population of all users. So the overall population of all users makes about 3.5 morning peak trips. With this, we're looking at people who made 0 to 2. This is their average number. And this is 2, this 2.5 here, so there's 1.5 down there. Okay? After the join, it goes up closer to 2.5 from 1.5. So it's roughly about 60 to 70% increase. Okay? And this was stable. It went there and stuck. Okay? The same thing for distance as well, not surprisingly. But this was more about which type of commuters are doing, the short distance or the long distance ones. And I didn't include that chart here. So those are all the things, and there's more to say with the Capri program and what do you do when you don't know what the before behavior is and how do you compare and things like this. So I will stop here, however, take any questions you may have, or we can go to the break and come back and I can resume.
Thank you. So we can take maybe a few questions and then continue to other questions offline. Anton.
So what is the advantage of this type of incentive scheme over just variable pricing?
It's can you pass that? It's a question of when you put it to the vote, it's not been very popular. Many places have tried but not been successful. Okay. In the US, we've got around it by having one lane, not the entire highway. Okay. That's the thing. Can you institute it more than anything else? And it's possible over time more cities will find it necessary to do it. But that's the main issue. Is it's not versus, it's no advantage. They're just two complementary ways of doing it.
Because in Singapore, if you drive your car, the toll you pay changes over time.
That's right.
So I would imagine people in Singapore are already used to this idea.
Yeah, so it started in 1975. Okay, I met the Minister of Transport from that time, Yeo Ning Hong. He made a very interesting comment. He said that when the press, when they launched it, with the electronic version, not the original, previously police used to write down a license plate, and there's pictures of that. Around the mid-80s, they went to electronic version with gantries and stuff. And he used to get these questions about like, often the press says you're intruding on my privacy, and citizens are like not happy because it's like, you're charging me more, okay? In fact, it's called electronic road pricing, and the government knows, and people say it's ERP stands for everyday raw people, okay? So it obviously just has a negative effect. People don't like it, okay? But it's necessary. The place is too small, and it has to. And they also regulate car ownership itself, right? So there's very different issues in Singapore. Places Singapore, Hong Kong, and Manhattan are very particular. They're all basically the small island-like things, and then everything is just different there, okay? But continuing on that, he made this comment, which he said, if he had the incentive option, he would have done both. Because he said, he told me, it felt like a two-handed basketball player. With just pricing, he felt like one hand. I thought that was a colorful thing to say. But anyway, you get the point. It's another tool you could use.
So Singapore also has a different scheme, right, on the MRT. They have one where if you leave out before 7:15, you get a straight out discount.
That's right.
Was that at the same time as?
No, the times were. So he's referring to something where, before we started, the mass rapid transit system had a flat. First, it started at 30 cents. You get a flat 30 cents reward no lottery, nothing. If you leave, there's that. And then over time, they also did the free version of it. Okay, apply to some stations, not island-wide. Okay, and you had to exit. There's some differences. Ours was arrival time. So this has been heavily compared and contrasted for that reason. Okay, this costs a lot less because of the lottery thing, and so they have different effects basically. Yeah.
Maybe one last question, and then let's continue offline. Go ahead.
Going back to your statement of, well, you have to commute. If we go back about 15 years, telecommuting was going to shave off this 5 to 10% and
Right.
attacking congestion. So what happened to, how did that hype cycle work out?
So I'm glad you're asking the question, and I think this is probably the most important question. I've worked on this for 8 years now, and now that urban is acquired by Google Maps, and I'm out of it in the formal sense, this problem still exists, right? That's why it's here, okay? I don't think the future of urban mobility is zero commuting. That's what I think, okay? I said this and it wasn't very popular, but I think that's the answer, okay? It's not popular in the valley because people like to, have employees in the workplace because that improves productivity, etc. But I think that's just an artifact of our current technology for distance interaction. Yeah, the reason I'm saying this is because there's a note I wrote for a class. The cost of moving a person is like this. The cost of moving a bit is like this. It's obvious that you're going to move this people movement to bit movement just because the cost is. The problem is the tools aren't up there yet. So I had an undergrad student do an audit of Stanford commuters on a daily commute basis, as well as the trips we take for conferences. And to in fact create a carbon footprint measurement for conferences. Like, so we have people from faraway places. But this is a good one because we're here for 5 months. So we're all in the right place, guys, okay? We do a lot of flyby, one session conference visits, okay? All the way to DC for one session and then go home. This is like a trend. If you audit the conference for footprint and see, that number is very discouraging. And there's no reason why we can't just have presentations online. Okay? And I think that's probably going to happen in 5 years. Conferences first, I believe. I think academics can make a huge difference there.
Let's take a coffee break and resume.